I'm Martin Beeby. I work... Ooh, that's gone on too far. I work at Microsoft. Has anyone heard of that company? Little Seattle-based company. I've worked there for 5 years. I've been a developer for about half my life. 16 years. I started when I was 16. I'll save you doing the maths. I'm 21 years old. I'm going to be talking about TypeScript today, and I'm going to try and do it in 30 minutes, which is the fastest I've ever tried to do it. And I'll probably fail, but I'll try. Does anyone here use TypeScript? One person shakes his hand like this, then no, you don't. Sort of, maybe. You've seen it, I'm guessing you're saying. Have you heard, anyone heard the word TypeScript? Cool, right, well then we're good. So we're going to be looking at what TypeScript is, which sounds like we're in a good audience because you've not used it. We're going to be looking why you would use it, and then finally how you would go and use it. Sorry about the size of this monitor. I think I've got some code, but hopefully it's going to be quite large on this 800 by 600 screen here. So when we're talking about TypeScript, we're really talking about JavaScript. Sorry, just to be safe, I'll just put that there. I'm not a JavaScript developer by trade, really. I'm a web developer. I've been developing web apps for a long time, but generally in the back end. So I'm a C# developer. ASP, VB.NET, C# was my journey into web development. And then JavaScript hit me like a slow bullet when this came along, which was Windows 8. And my employer said, well, you're really good at C#. Why don't you just transition over to JavaScript? Because you do a bit of webby stuff. You know what you're talking about. To this point, I've really only done like hover animations in jQuery. And what they're trying to get me to build was native applications in JavaScript. So if you're aware of the Windows 8 sort of development paradigm, you can either build in C++, C#, or JavaScript. And JavaScript gives you access to all of the native functions that are in Windows. So they have a Windows API directly for JavaScript, which correlates directly to the C++ and C# APIs. So you can build very, very complex apps in JavaScript. And when I kind of started into this world, I spoke to a developer friend of mine who said, oh, well, I was telling him about this sort of transition to JavaScript and how I was kind of uncomfortable a bit with it. And he was saying, well, you know, you should be fine. Like C# is pretty much Java. JavaScript's obviously a subset of Java. And I was thinking, hold on a second. JavaScript isn't a subset of Java. It's a whole different thing. It's a prototype of functional language. It's ridiculously different. It's as far different as you can get. It's like F# to C#. It's a huge difference. Java is to JavaScript as car is to carpet. They're completely different things. But this is quite a common reaction I get from C# devs which come to this world. And there is this sort of slow realization when you come from a statically typed language to something like JavaScript, which is dynamic in its essence, of just how do we manage this stuff? How do we build things of scale in this? Because all of the things and constraints that I have in C# just no longer exist. So this is one of the first applications that Microsoft used TypeScript to build, of any note, really. It's over 100,000 lines of code, and it's the Xbox Music app. And it runs on Windows 8, so it's the default music application inside of Windows. And it also runs on Xbox. Same code base. Xbox One, I should add. Because the idea that you should be able to build these applications, then run across the phone, Windows, and Xbox using the same code base. That's the idea. It's a very complex application. The reason why you get to 100,000 lines of code is because you're doing sorts of things that you wouldn't necessarily do in web pages. We're doing things like DRM. We're doing things like file, big downloading the files off the network. We're storing large volumes of files. We're iterating over huge library collections. We're doing home media server connections, all sorts of things that this application does that you wouldn't necessarily do in websites. And so you need a lot of lines of code. There's lots of features. And as an effect, Microsoft put a ton of developers on this. It's not a couple of developers. It's a big team. There's a PM, there's a few PMs, there's a big test team. And we started realizing very, very quickly that JavaScript, when you're doing it at scale, is very complex, especially when most of your developers aren't JavaScript experts. And so we wanted to come up with a way of solving this. There were other projects at Microsoft as well, like Visual Studio Online, which is an IDE. Visual Studios are like premier development tools. And we've recently added a feature that you can use these tools, or you can use an IDE, but in the browser. So if any website that you have on an Azure, Microsoft Azure hosting, you can look at the files and then you can go directly into an editor. And it's a full editor. It's called the Monaco editor internally. And it's a component. It's an editor which we use across everything. So on the TypeScript website, they use the Monaco editor. over here, inside of the Visual Studio Online, they use the TypeScript editor. In F12 tools inside of Internet Explorer, the DOM Explorer is the Monaco editor. So we use it in lots and lots of places. And we use TypeScript to generate all of that complex code. And both these applications, the Xbox Music and Visual Studio Online, tens of thousands, hundreds of thousands of lines of code, hundreds or tens and tens of developers working on it. So TypeScript is, I guess, what we invented internally to solve this problem. And we put our best man, our best languages man on the job. A guy called Anders Harsberg. Has anyone heard of Anders Harsberg? He's the inventor of C# and other cool languages. And we kind of gave him the challenge of, well, how do we want to work with JavaScript. How do we do it? How do we use certain features that we want to bring from other languages? How do we bring that into JavaScript in a useful kind of way? And Anders started out on this road. And one of the unique things about this is it was in this whole wave of when, about 4 or 5 years ago, I guess, when Microsoft is starting to look into being more open as an organization. And it was one of the very first sort of things which we started doing open source. So just to point out that when it's a typed, this is how Anders describes it, a typed superset of JavaScript that compiles down to idiomatic JavaScript. So it should generate JavaScript that is the sort of JavaScript that you would generate anyway. It's not garbage that you couldn't read or special performance enhanced JavaScript, or it's not trying to do any of that. It's just going to generate high quality JavaScript that you would ordinarily produce by hand. It's open source. It was launched on Codeplex, which was our open source platform, and it's now on GitHub, along actually with C#. That language specification is now open source and is on GitHub as well. You get TypeScript in a number of ways, but the easiest way is just to install it via node npm. So npm install, and then you globally put TypeScript in there, and then you can just from command line or terminal put tsc and then provide your file, your ts file, and it will convert that ts file into JavaScript. So just to look, this is very small, you're not going to be able to see this. We would take some just standard JavaScript, we would put it through the compiler, and out would come idiomatic JavaScript. And it's kind of, prototypes. We start seeing things like you would expect to see in JavaScript, like prototype inheritance. We have prototype object there, which we're extending. So we're doing the kind of classes and so forth in the way that you would do it in JavaScript. But when you write it in TypeScript, you are kind of, when you're writing in TypeScript, you're using things like classes, constructors. You're telling the objects that they're types of string and the kinds of things you would get in more of a statically typed language. So TypeScript, take any JS file, change the extension to TS, and it is TypeScript. So if you don't choose to decorate your code in any way, the TypeScript compiler will take your existing JavaScript and just compile it. And this is useful because it means that you can adjust existing JavaScript files bit by bit by bit. You don't have to go whole hog into TypeScript. You could just make one function in TypeScript and the rest remains static JavaScript, and it will still compile. So for example, if we took some vanilla JS, and this should hopefully be a little bit easier to read, just a function. I've got a name property called foo. I've got a var, x plus x, and then I'm alerting it like it's 1999. So I take that x. Now, in JavaScript, that x could be anything. It could be a string, it could be a number, it could be nan, it could be null, it could be whatever. But I'm not telling any constraints. I know as a developer what I expect process to be accepting, but there's no way in JavaScript to tell it. The type system which exists in JavaScript only really exists at runtime, because when you try and do certain things with types, it will tell you there's a problem. But the TypeScript, when you're writing it, in JavaScript, there's no way of telling the compiler what you mean. Well, TypeScript, if we wanted just one thing to make this a TypeScript file, we could just say, well, x is a string. And immediately, the compiler would come up with a problem with that file, because it would say, well, if x is a string, then you can't call a .name property on x, because x is a string. It's of type string. And there are 3 types that we provide out of the box: string, boolean, and number. But you can obviously add your own types, and we'll come to that later. So we only expect process to ever accept a string, and then if we're calling something like .name on a string that doesn't exist on a string literal, it would throw at runtime. So we alert you there at the compile time. As you write .name, it will underline red squiggly, like in Word, and tell you it's all wrong. And this is key. I guess we're adding a compiler, and compilation in many languages is the first unit test. So in C#, you obviously have a lot of your unit tests running in the background, but the first thing you want to try and get when you first get a project running, you want to make sure it builds. In JavaScript, you don't necessarily have that build step. If you've created a big test harness, then that's great, but there's no way other than executing your application you can tell if it's going to work in the way you expect it to. With a compiled application, obviously you can, and TypeScript gives you that kind of flexibility, that compilation step. It's your first unit test. We have a number of different IDE support. So the compiler is open source, so people have written extensions to existing things. We write the one for Visual Studio, clearly. We have Sublime, Vim, and Emacs support. I think the Microsoft team worked on those particular IDEs to get support. And then, obviously, inside of Visual Studio and Visual Studio Online, we have TypeScript support as well. And what I mean by support is it will do things like IntelliSense or code hinting, depending on the IDE you're using. But it will tell you when you click dot what properties you could use on that object. It will alert you when you're making mistakes or calling properties that don't exist on objects. And really, when Phil was talking about earlier about constraints and embracing constraints, this is a way to enforce constraints, really, on your project and describe the intent that you have when you're developing your JavaScript. So we could make that process function accept just a number. And here we have, v, x plus x, and then we're alerting v. What TypeScript's able to do, obviously, is it infers, because x is a number, x plus x, then v is obviously a number. So the type, by adding just a small piece of type information in the top that x is a number, you can start to infer type. That, if we're going to plus two numbers, then the result's obviously going to be a number. So v is clearly a number, even though we've not declared it. And you'll start to see that in TypeScript. As you add small elements of type safety into your application, it starts spreading throughout the application. We can add Boolean. So if we added a Boolean type to this function, var plus var, you can't add Booleans in JavaScript, so it's going to come back with, you can't add Booleans anywhere, but and so that's going to alert as a compile error because you're clearly trying to do an operation on a Boolean which it's not intended to do. We can also have more complex types. So we could have a string array. So we could take an array, a string, make it a string array, and then if we took x and put to the 0 point, when we pressed dot, this is Sublime code hinting, it's going to give us the properties that exist on the string object inside of JavaScript, so to lowercase. So we're starting getting code hinting. And the important thing is that we're not having to do very much processing here in the background to actually run and execute this JavaScript in the way that an IDE traditionally would have to do this, because we're providing a lot of the type information. So we're making an IDE smarter and cleverer. I talked about interfaces earlier. So if you wanted to create your own types, so if you want to create an application that couldn't just run on bools, numbers, and strings, God forbid, and you wanted to have your own type or class definition, well, you might create a class, or you could create an interface, and that's quite common. So an interface is just a contract to describe the shape of the object that's going to be passed to the function. So process now accepts a thing, or something which inherits thing or looks like thing. And so as long as the thing which gets passed to process has a number and a string, then that'll be fine. It will be accepted as that type. And that's how you would write the thing interface, and that's how you would add it to a property or a function property. And obviously, we're doing type inference here as well, that because thing is a number, and we pass thing in, when we pass the object, which looks like a thing, then we can know that the n, even though we don't declare that n is a number, because of the interface, it works out, the IDE is able to work out, or the compiler is able to work out that n's clearly a number, so we can intelligently say, well, when you press dot, it will give you number-like properties that you can execute on that number. It's duck typing, so if it walks like a duck and quacks like a duck, we consider it a duck. It's if an object when you have an interface, as long as the object looks like that, it doesn't have to inherit, it just has to look like it, the same sort of shape, we consider it the same object. It's duck typing. This is useful because if we've got an interface which has got number and string but doesn't have a C property, which is Boolean, but then adds a C Boolean property, but then somewhere in our application, maybe the 15,000 calls to this one function, there is one of those calls that doesn't include the C parameter, well then we can alert in the compiler that you're calling a function which expects a thing, but you're actually providing an object which doesn't look like a thing. And that's a really common thing that you get in JavaScript, especially in large code bases where you make a refactor, you change a function, but you don't necessarily find all the definition, the calls to that function to be able to change them. What we could do, if say we sometimes want it to be a Boolean, sometimes we don't, then we could have optional parameters or optional members. So we could say, well, C is optional. We'll just put a question mark next to C, and then we can call it with just an A, B, or we can provide a C property, and it will be fine. Our interface can include things like functions as well. So this declaration here, foo, says there's a function which has two parameters, x and n. One is string, one is number, and it returns a string. That's the interface declaration of the thing interface. And then it means that when we get a thing, we know that it's got a .foo. So when we start typing this stuff, .foo is going to come up with our code hinting. It's going to know that that's thing. And we know that this process then returns a string because the interface declares that thing, that foo returns a string. We're returning the product of foo, and so process by definition must be of type string. So if I go here and I put in return.foo and I provide a string, Jeff, you'll see that it requires a number. It's not optional at the moment. But I can make this one optional as well by just adding a question mark. And then I can call foo with an optional n parameter. Now let's say actually foo isn't just, I don't just want to have two parameters that I pass in. I want it to look slightly different than this. So you can't see this at all, definitely, but IntelliSense is code hinting me all the time, telling me what properties I could pass to this parameter, this API. So maybe I want to create overloads, a concept which isn't that common in JavaScript, but I could say, okay, well, I want to actually have when I do foo, I want it to accept either string and number, but only string and number, not bool, not any other type. So what I can do is I can take this thing, this line of code, this foo declaration, can duplicate it, and change the parameter it accepts to number. And now, of course, in the editor, I'm going to press .foo, and it's going to have two overloads. It's going to have an overload of type string and an overload of type number, because we've said that it can have duplicate overloads. So that's all cool. So that's the same thing in Sublime, the editor. So this stuff it's a language feature. It doesn't, because the compiler's open source, you can add it to any kind of IDE, and this is the Sublime support for it. So it just shows that you've got two overloads. There's a problem with kind of this world, though. In JavaScript, most JavaScript that we need to be able to model existing JavaScript out there in the world, and that's sometimes quite difficult because they often have very different kind of properties. And one of the things we could do, we could change the syntax of this slightly, and it's the same. This is exactly the same now code, but now I've just declared it in a slightly different way, and it means that I could say on foo, as well as it being a function, I also want it to have a data property. So now I can, with this declaration, say data is a property of foo, although it's also a function, which accepts two types of parameters, and data is of type any. That's really the fourth type in TypeScript, any, which means anything. It's dynamic. But you're just sort of stating it, that it's anything, and it can be anything. So now we can say foo x.foo, instead of calling the function x.foo.data, and that's fine. And we need that to be able to model existing JavaScript libraries which are out there in the world. Well, never mind about this bit. The other thing that we can do is we can create an interface, say something like a wrapper interface, and then we can create a function which explicitly implements that. So a function which implements that interface, wrapper, and then if we try and implement it with the wrong property, so clear here and I've put clear spelt wrong, then that's going to be alerted at compile time. That I said that there's a contract between the function and the interface, and I'm not adhering to that contract. One of the things is important to remember is that when I said we had to model, to get this kind of IntelliSense, not only your app has to be built in TypeScript, we have to have some way of describing the whole DOM API in TypeScript. But we did that for you, and we did it also for a lot of third-party libraries as well. So if I go to definition on client X, it will take me to the complete TypeScript implementation of the DOM API. And what this fundamentally is every DOM API that's possible, according to the specification, we've written an interface for it. So type safety, as you're typing, so if you create an element or whatever, we know all the properties that are possible on an element because of type safety, because of this implementation. So we've done it for the whole DOM API, but there are definition files for almost every third-party library out there. And really, creating definition files is pretty straightforward. You just create a load of interfaces for those, and you can describe and model those definition files, and then use those TypeScript libraries inside your type app. Fat arrows solves a problem. I don't know if fat arrows is the technical term for that, but I always call it, that's what it's called in C#, fat arrows, or a lambda arrow. And this helps with the this scope in JavaScript. So, for example, we have, you probably can't see this, but I have a very common piece of JavaScript where you have an on-mouse over function, and I'm incrementing the this.count method. But as JavaScript developers will know, that this doesn't always mean this, depending on how it's executed or attached to, because of the way that JavaScript works. And what fat arrows can do for you, I want to go across this because you won't be able to see any of this code because it's all too small. Fat arrows can allow you to, when you are trying to encapsulate a function, if you wrap it in a fat arrow, TypeScript does all the heavy lifting of making sure that it has private backing fields in there. So if I just take, this is the issue. So if I just change this declaration from function E, like an anonymous function that I've got here, and add a fat arrow declaration, this is one of the pitfalls of doing videos, e.fatArrow. It sort of encapsulates this this constraint. So now you'll see that we've actually added an internal read-only property called _this, which captures the functions, the state of the this object. And that's what you would do in regular JavaScript, but we're just doing it in you write a really nice syntax for that, and then we just add all the disgusting kind of hacks to make it work. So classes, building classes in TypeScript is kind of a cool thing. This is what a class might look like in regular old JavaScript, and you've got that prototype sort of stuff. And this is really quite scary when you explain to someone which is new to JavaScript how this is how you create classes in JavaScript. They freak out because it's like, well, what is this? I've never used this. Most people have never used prototypal inheritance in a language. Well, TypeScript would make it look similar, but it would generate that exact same JavaScript, but you're going to have things like a class name, a constructor, which you pass ref things to, and we have methods on those things. And we call it in exactly the same way, and it does actually generate the JavaScript we just saw, but we write it in a much more familiar way for regular sort of non-JavaScript developers. We have a concept of modules, which you can wrap a class in a module, and it sort of namespaces it, I guess. So now this same class, the greeter class, is now wrapped inside of the sayings module. So we say new.sayings.greeter when we new up this object, and it generates all the stuff for us. We have AMD and CommonJS support in the library as well. So if I've got the require.js thing, and then the app.js is my entry point to my application. I go to my TS file. I'm importing the greeter file, and then doing some work with it. And the greeter file, all that is a class called greeter, which has some properties and so forth on it. And what will happen, require.js will load those JavaScript dependencies at runtime for us. Fundamentally, types make tooling easier, and we can do some really cool things with types. So there's things like code hinting, which is a nice feature, but we can do so much more. And we've been doing stuff in the C# language. We created a new compiler called Roslyn. This took us about 8 years to write that C# compiler. And we're actually, interestingly, in the new version of Visual Studio, getting some of the benefit of that in JavaScript. And what I mean is, what I'm about to show you is not that, you might look at it straight away and think, well, everyone can do a rename refactor, but we can do this over hundreds of thousands of lines of code really efficiently, really quickly, and very, very reliably. So if I am inside of this file, we've got an app on the top-hand side, and we've got called greeter. And if I rename this file or rename this class from the declaration, it's actually renaming it everywhere in the application which calls this class. And I'm just showing you the two classes, the actual declaration of a class and the implementation. And as I change it in the implementation, it's actually changing it across the whole project. And it's not doing this in a kind of find replace string manner. It's doing this in it understands the structure of our application, and therefore it's only changing the name of that actual class which actually exists. It doesn't change greeter here, which is a string. It doesn't change greeter, which is everywhere else in the application. It's not doing a find or replace or find in all files. It's doing a name and replace of elements which are, of only the things which are in our application which actually relate to that class. And we can also do another thing, this thing called peek in Visual Studio. So if you're kind of wanting to see an implementation, say, of a function inside of Visual Studio, this has been available in C# for an awful long time. We can just right-click it and we can say peek. So we can right-click and peek. And then inline inside of that editor, it opens up a sort of preview of the page or the implementation, so you can see it. So it's a really nice way to jump. You don't have to open lots and lots of files all the time. You can just peek definition, and see the implementation of a function in line with the current code. And the way that we're able to do this is because we understand the structure and syntactical structure, the syntax tree of your application. Obviously as well, every kind of, if you want to see how we implement a particular function, you can right-click and say go to definition, and it will take you to that specific file where it's implemented as well. It's a great way to manage, as Phil was saying earlier, like when you have thousands of files, finding out where actually that class is defined can be quite complex. So having your tools be able to tell you where that class is defined is really useful. We also support the concept of private variables. So on a project, you can say that X and Y are private. What actually happens when it produces the code, there's no idea of public or private variables. So that doesn't exist in JavaScript as a concept, certainly in ECMAScript 5. But it does, it's kind of, we only use it as compilation here. So we're not adding any kind of security structure to your application. What we're doing is we're just saying, if you're saying it's private, then you try and call that property, and from externally, then it's going to tell you there's a problem in the application because it's a private variable, and the developer of that API decided that for whatever reason, you shouldn't be able to change that private variable. So it's a way of sort of declaring intent, but actually it disappears. It's 0-calorie typing. It completely disappears when it actually generates the JavaScript. We can also do inheritance, and this is probably one of the most useful features of TypeScript, is that we can create an animal base class, and then we can extend it to create a horse, or whatever you want to create. And you just use this extends keyword. So horse extends animal, and then all of a sudden you've got all of the properties of that other class. Now, if you've ever done this sort of stuff in JavaScript, you'll know it's quite a lot of long-winded code. And to the point that here I have a class called point, and I'm going to go and implement, and this is, at the moment, this is TypeScript and this is JavaScript, and it's a similar amount of code that you're writing. But if I want to take a new class and extend point, which implements the iPoint interface, it starts generating kind of, you start having to add quite wacky code to kind of mimic this or to create this in real JavaScript. And this is the only time that TypeScript actually adds anything into your JavaScript which is more than syntactical sugar to enable the extension or to enable class inheritance. But that's the JavaScript TypeScript, and then the JavaScript is along this whole page, and then it carries on to another page. There's a lot of code that you need to do inheritance in JavaScript. And this is a far, far, far cleaner syntax. We also support generics. God, that's small. I'm not going to go into it then. We support generics. We also recently added the support for tuples as well into the language. And as I said before, you can use TypeScript with any third-party library. We have a GitHub repository called Definitively Typed, which lists all of them. So if you want to use Ember.js or Angular or Knockout or your noun, pick any noun in the world, .js. If you want to use that library, there's probably a typing for it inside of definitively typed. So that's TypeScript in a whirlwind. I'm running over by about 3 or 4 minutes, but if you do use TypeScript, do let me know. If you have any problems with TypeScript, do let me know. And I've been Martin Beeby. Thank you very much.